先把你变成 host。
我现在已经是，我看一下，我应该在，
这样就可以，这样就可以了。
你这个应该是在云端吧？感觉。
对，这样，然后等一下会在我的 email，我再传给你们就行。你就
OK，
中途不要把它 stop 就好，你结束的时候
我
再
我就是我不一定放心，那行吧，希望不会出问题。OK，
可以。
嗯，行，拜拜。哦，Hello，
Hello.
yeah, we shall wait.
Yeah,
Uh, yeah, I think it's starting to record, but we shall still waiting for more people. So maybe we will have 1 or 2 minutes later. Yeah.
yeah. So it's early. It used to be 8 o'clock. Now 6. Oh, 7. Oh, 6. 2 hour earlier
Yeah,
than before. Yeah.
yeah, and since a lot of people in the East, I mean in the East Coast, they tell us it's hard to join our meetings.
Oh, okay. Makes
We
sense.
make it 2 hours um before. But anyway, I don't know why others don't happen to join. Yeah, I gotta remind them to join. You know.
Yang, you are at Los Angeles, right?
Yeah.
Yeah. Is this the cold there? Like it's winter now. Snow?
It's
Uh-huh.
gonna be cool. I think Los Angeles is much warmer than San Francisco. Yeah.
I see. Good.
Okay. Yeah. Hello, everyone. We shall wait for maybe 10 people and maybe 10 people to start our meeting today. Yeah. Okay. Hello, E. And now we have to. Yeah. So. I think, yeah, thanks for joining today. And as we've discussed, we've moved our meeting 2 hours late, 2 hours before, since a lot of people in the East Coast tell us it's hard for them to join. So right now we have our meeting at 6 o'clock, and it's a bi-weekly meeting. And at the beginning, there's happy Thanksgiving for everyone. Yeah, and we got to starting our meeting right now. Um, okay. So hello everyone. Today, yeah, we have several things to discuss about, and basically, it's Basically, we will discuss about all our new features in the 0.4 release version, and we mainly discuss about these kinds of unique features in the open source community. So, so today we got discuss about three core features today. And the first one is the data parallelism router, and the second is data parallelism attention, and the last one is online weight updates for RHF. And okay, hello everyone, thanks for joining. Right, and since Ying and Ke maybe they will be somehow later, so I will start the meeting right now and discuss about my part. I mean the online weight update API for RHF. Okay, hello everyone. Yeah, nice to meet you. Okay, yeah, thanks. I gotta share my screen, right? Okay, right. Could you guys see my screen, right?
Yes, yes.
Okay, so let me start it. Yeah, I seldom use how to somehow like how to present it. Are there any button? Oh yeah. Okay. Hello everyone. Today, I will have maybe less than 10 minutes to discuss about our new feature about the online weight updater from distribution. It seems quite weird since if you do care about our documents, you can see that we have an update weights API right now, and for that API, you can directly launch an engine and always update the weights in place from the disk. And that's right now we call it update weights from disk. And if you do play with that, we'll find that this API is quite well right now, but we still need to make it better for RHF. So the first thing I'd like to discuss about is why we need these kinds of weight updates in RHF. Here's a picture I drawn from the Nemo and Niner paper. That paper is regarding NVIDIA's RHF pipeline and their toolkits for thousands of GPUs RHF. And right now you can see this is the progress, somehow a really naive progress of RHF. I won't go deeper into any step, but we've definitely see this. You see that at this point, SFT model will be initialized into the policy, we will call it actor. And also a reward model will be initialized into the value network. We also call it critic. There has thousands of prompts. So for each rounds of RLHF training, the policy model will do inference on the prompts, and somehow its response will be judged by the value and to give some feedback to the policy model. And later the policy model will be updated. So we can see that we can just regard RHF as thousands rounds of weight updates and rollout. For each step, it will roll out on these kinds of prompts and gets the feedback and updates the parameter and do it so on. So we can see the model weights will be dynamically updated. How can we do inference on that? The most easy way is that we can relaunch the engine thousands of times. So each time you train the model for several steps and you save that checkpoint to the disk and you relaunch the engine, right? And that's pretty slow. Like relaunching one engine would take like 1 minute, right? And a second way is that we already have, right? We can directly update the weights from disk for our online engine. We just need to somehow we just need to fire up the engine for once, and later for every step, the training engine would update the parameters of the policy model and the value model, and we save these checkpoints to the disk, and later we update weights from disks and to reload the engine, right? And that's the second way we already have. But the third way is that could we do it much better? Like we do not want to save the checkpoints to disk, since these kinds of saving and reading could also take a lot of time. Otherwise, we can directly somehow get the weights from torch distributed, and that's what we have right now. So in this case, we launch the engine for once, and each time the parameter of the policy or the model will be updated, and we directly use torch distributed to broadcast the parameters into the engine, and we let the engine workings always keep working. Yeah, and that's the basic idea. So here's the two core API for this utility. First is initialize wait update group. Yeah, the idea is pretty simple. Just reinitialize a touch process group. And the second thing is that update parameter from distributed. Here's something I need to stress that this is update parameter from distributed, not update the whole, not let's not update the whole model at once, since in the real RLHF training, you always have to concatenate your weights to rack 1, and from rack 1 to broadcast your weights to the other racks. So for every time you can just update one parameter but not the whole model. Yeah, so that's called the update parameter from distributed. But you can also call it update weights. You have to know that this name is the name of the parameter. You cannot directly broadcast the whole model at once. Yeah, and that's the two core API for this utility. So right now we can. So right now we have we have all the functionality working, and and you can see the utilization in this test file, and we will merge it in today on tomorrow. So the basic usage is that, as I've described, we first launch a Hugging Face model on rack 0. Note that maybe rack 0 could not host all the model, but in any case, you can first broadcast the Hugging Face model to rack 0 and to broadcast from rack 0 to the SGLang workers. And the second thing that so that's why we say that we can assume we will launch a Hugging Face model on rack 0. And later we launch SGLang engine runtime on rack 1 and so on. Here I said DP is supported, so we can launch multiple SGLang engines, maybe rack 1, rack 3, and rack 5. And later, after launching all these engines and RHF models, we can start to broadcast and load the parameters. So there's a naive test case on our H100 cluster. Broadcasting an 8 billion llama model takes less than half seconds. So that's the feature of this support, and we hope it will be integrated into OpenRLHF framework these days. And okay, and that's all I have today. Are there any questions on this part? Okay, hello, are there any questions on this part?
Hey, I have a question. Chen Yang.
Okay. Oh, okay.
So what part determines the update rate? Like you're saying, using torch dispute to get update.
Yeah.
So is the publisher determines the update rates, or how is that? Can you elaborate a little bit more on that aspect? Who determines the update rate? For example, you're doing fine tuning, you continuous update the trainer. The training process continue or fine tuning continuous update weights, right?
Okay, so maybe I can maybe let's take this picture for elaboration, right? Let's see. Sorry, I gotta share my screen right now. Okay. So in this picture demonstrates how RLHF basically works. You have a pre-trained model and you SFT it for one time, and you get the SFT model, and here the SFT model would get preference model fine-tune and gets a reward model, and we take SFT model and reward model, initialize the RLHF process. You can see that the RLHF process can be regarded as thousands rounds of update and inference. for each time the inference is quite you do not need to inference a lot, say like less than 100 examples is enough to see the preference, but you have to do it thousands of rounds. So that's the frequency do we update the model. And scientifically speaking, right now rolling out launching an engine and doing inference could take more than half the time of the RLHF. So in this case, if every time relaunching the engine takes you 1 minute, you can see that in the whole process you will relaunch the engine for thousands of times, and that's really expensive. So do our leaders settle your concerns?
Yes, I think so. Yeah. Yeah. Thanks.
Okay. So
Yeah, hi Chen. Maybe I have a question.
okay.
Yeah, because I saw the API that you introduced. Yeah, I'm just wondering whether the initialize weight group, that API will cause any rigidity in terms of the the program writing, because I saw that you need to pass you need to pass some parameters like master address, master port into that API. Yeah, and that looks like you are initializing the distributed network from scratch instead of just initialize a group.
Okay, sorry. So, you're questioning about the initialization cost of the init parameter update group, right? Am I clear?
Yeah, no, I'm not talking about the cost, but just talking about the way people write programs for distributed training. Because when people use PyTorch, they will basically call the Torch distributed init process group to initialize the NCCL network first, right?
Yeah.
Then when they create subgroups, they just call the dist new group API.
Oh,
And it seems that you put these two parts into one API. Yeah, but what if in some code base people initialize the SSL network first? Yeah, which means that part has already existed in their code. Yeah, and you just repeat that part again in your API. Would it be necessary to include the SSL network initialization in your code? It seems that I think only the group initialization is needed in your API.
Okay, thanks. I think you've touched the core of this API. Right now, you can see that this API has a lot of and these parameters like the master address, master port, rec offset, and group name. If you do remember the parameters of Torch native initialized initialized process group, there's only several of these parameters, and if you initialize this process group twice, it will run into error, right? So
Yeah, right.
So we have a wrapper for the Torch native initialized group, and to support all these parameters, and you can check our codes, and also and you can check our codes in the SGLang utils, and we have initialized custom process group, and that's a wrapper for this. But right now we are trying out to directly use Torch native initialized group. We will work on this these days, right? Thanks.
Yeah, okay. Because based on my past experience, I'm not sure whether wrapping will do any good to the users. Just sometimes they wanna modify these things, then they have to extract that part out. Then maybe they want to play with their own distributor setting. Yeah, this might cause some conflict. So yeah, just a question on the necessity of the wrapping part. Not sure whether it fits in your context.
So yeah, Damien, do you have any comments for this?
Yes, sorry, I was late. I didn't remember we changed the time. Can you remind me of some of the context, for example, your slides, and what's the question?
Okay. I will show you the slides, but the question that do we really need these kinds of wrapper for the Torch native in process group?
So sorry, like, can you share
Yeah.
what are the questions? I just like.
Oh
can
yeah, okay.
I
Okay,
missed.
my question is that because on Chenya's slide, especially for the first image, as you can see, there's an API called init wait update group, and some parameters like master address, master ports, word size are passed in, and even the backend are passed in to this API. And this basically looks to me like this API is doing two things. Firstly, it is initializing the SSL network. And secondly, it is creating a group for the wait update. Yeah, so I'm just not sure whether, we want to wrap these two things into one API, and especially when people are, some people are used to initialize the SSL group with the Torch native API. So I'm just wondering whether this kind of wrapping is necessary, or in this case, if the wait update group is a subgroup of the global process group, maybe it is better just to initialize the subgroup, and we don't have to pass parameters like master address, master port.
Okay, I see. I get a point. So let me try to explain here. So basically, I think the Chengyang, can you share the slides?
Yeah, I'm showing. Yeah.
Yeah, I think the current API should be correct. This is because, for example, if you like, I don't think this is a subgroup, because for example, you have a training job, and typically maybe in this case, I think OpenRLHF they use deep speed, so they already have a group, and now
Okay.
yeah, that's original in the training code. So we don't want to change any of the training code. So we should be able like to just to run the existing training code, and they have their own group, and then that's there. And then now we want to create a new group. This group will include like a totally different set of GPUs. It's not it's not a subset of the original GPUs, because it will include like some more inference GPUs. So I think this is now like a new group. So maybe now it's better to like set something very like totally reset everything for this new group. And this
Okay. I see.
they will have a different word size because the number of GPUs is different. And also
Okay.
we have many inference engines, so they will all start from different ranks. So the ranks are also different. And maybe but the port, I think the address and the port, maybe we can reuse them, but this will be a different group, not a subset, also not a superset. It's a
Okay.
different set.
Okay. Yeah, that sounds good.
Okay. Yeah. Are there any more questions regarding this part? Okay. And if not, we can move into the second part. Yeah. Maybe the data parallelism router and data parallelism attention. Ke said he's not able to join, so let me could you describe his part, like the
Yeah, I will work through that part.
Okay. Yeah. You can share the screen if you didn't.
Yeah, let me share my screen. So yeah, this is an optimization we did for right now it's mostly for DeepSeek models, but it will also be applicable to other models. So basically for DeepSeek models, the problem is they use the MLA architecture. So then they only have one KV head. So but if you want to run it with tensor parallelism 8, so you want to partition the KV heads by 8 shards, but there is only one head. How can you partition that? So typically people have to duplicate this KV head, and then this like basically you waste the compute and memory. So here like a better method to deal with this kind of attention is to run data parallelism for attention layer instead of a tensor parallelism. So I think last week we merged the one commit, merged one PR from Ke. So basically we will run data parallelism for attention, and here is how it works. if you can look at this figure. So we have many batches, and then when we go to the attention layer, so here we call MLA. When we go to the attention layer, every process they just run its own. They can be prefill, they can run prefill, or they can run decode, or they can be idle, and all of them have their own KV cache management. So they will just totally independent, just run their own batch and do their own prefix matching and everything, and memory allocation. And then when they go to the MOE layer, we will do an all gather to gather all the batch. So this is because we want to transform from data parallelism to tensor parallelism. So here we'll do an all gather to gather all the activations. And then when we go to the MOE layer, we will run tensor parallelism. And then here they will like share they will share the current batch and share that. And then after that, after the MOE layer, we can do a local slice again to slice their own batches here. So then we go back to data parallelism. So basically we are alternating between data parallelism and the tensor parallelism. By doing this, we can remove all the redundancy on the MLA layer and then run it much more efficient. So here we share some benchmark numbers. This is an old version. I think we are running DeepSeek models on H100, and this is old SGLang version. We have the simple MLA optimization, and this is new SGLang version. We enabled data parallelism for attention, and you can see for decoding, it can greatly increase the throughput. Yeah, I think this is a very cool optimization. So basically, we can flexibly combine different candle parallelism, and also there is ongoing PR expert parallelism. This is also from a contributor. So we can also combine the expert parallelism with data parallel attention. So ultimately, if we want to run DeepSeek models for high throughput, we can run data parallelism for attention and expert parallelism for MOE layers, and then switching between them. And then this will give us highest throughput. And I think we also tested this PR. This one is also compatible with the data parallelism. Okay, yeah, this is a high level overview. Do you have any questions?
Hey, this great work. I mean, this is I have a question here. I see you have enabled DP attention and also set DP size. So DP size can be different than the TP size, right? In theory.
Okay, I think this probably wrong here. I think the DP size here will be set automatically to be the same as TP size. Yeah, I think this is probably wrong.
I see.
We'll fix this.
Mm.
But in the future, you can imagine, yeah, the DP size can be different than TP size.
Yeah.
Yeah, so I think that's something we can support. And then you can tune the combination of DP and TP and potentially get better results.
Yeah. And the other thing I have a question here regarding this picture, the slice part. Would the slice, the result of slice will be consistent with initial, like on the top, incoming batch? Would it be shuffled or go to the same logically? Like say the left side batch one will be end up at the bottom the same top and the bottom, or there's totally reshuffle.
Yeah, it will be the same because that's how we because each data parallelism rank it has to allocate the memory. So like each layer it should be the same. Otherwise, you need to reallocate memory and all these things. That will make things different. Yeah, but this is a good question here. So because we want data parallelism for attention layer, so it will cause some workload imbalance. This works well for high throughput settings where the server is always fully loaded. But in some cases, we need to reconsider load balancing.
That's right. And also, like PR, you mentioned, now we have DP, TP, and EP. There's one thing I was thinking we have not probably start to implement it is can we go a little bit further ahead to say I want to control this per layer. Like I don't want to treat all the layers the same way. Maybe for example, take EP and TP for example. At the beginning of network, I think if you do EP, node balancing might be less a concern. But at the end, right, at the head of like output side of network, EP might be more leading to imbalance because higher layer of feature map might be more how do I say?
Okay, yeah, I
Little bit
understand
less, right?
yeah, I understand what you're saying, but I think that that's something in a different degree. Because here, like we are not balancing, we are not doing load balancing within a single MOE layer. I think you are talking about something like
EP,
inside the
right?
MOE kernel, but we are doing that at a higher level.
Mhm.
So yeah, it's not related to that. For that one, we can do something inside the MOE kernel to manage to do it better. But here we're talking about like parallelism.
I agree. I'm just gonna think about something extra, but that's fine. Yeah.
Okay.
Yeah.
Yeah, I think for yeah, okay, maybe I was wrong. Yeah. Okay, so you're thinking about
Per
doing
layer,
expert
per layer level,
layers.
right? Per layer control, EPDP, EPTP, and EP. It's possible, right?
Okay. Yeah, it's totally possible. Yeah, I think
Yeah.
that's possible. Yeah, I probably was wrong. Yeah, I think you actually proposed some interesting ideas. We can try that. That's very easy to try. I think all this expert parallelism, tensor parallelism, data parallelism, you can flexibly combine it. A data parallelism is slightly different. You cannot easily configure them, but tensor parallelism and expert parallelism, you can easily switch them.
Okay.
Okay.
So it's not SNICE, right? At the bottom, the SNICE really recover the same split from the top. If I understand the naming's point.
Yeah.
Okay. It's very cool.
Yeah, so that's what this part. Ke is here. And do you have any comments, Ke? Hello.
Yeah. Yeah, I have no comment. Yeah.
Okay. Thanks for the great job. Okay, and the next part maybe the router, but I guess we have described it for several times. Um, I don't think it's here, so maybe we could maybe skip that part.
Yeah, I will also quickly go through this part.
Okay.
So yeah, we have talked about it last meeting. But at that time it's still experimental. But now I think it should be fully ready. And several companies like LinkedIn and Game Studio, they are trying this feature. So yeah, so basically it can be basically the load balancer. Our goal is to make a cache aware load balancer. So every time when there are multiple replicas, we can correctly route the request to the worker with the cache, and we run some benchmark, and you can see the cache hit rate and is significantly improved, and the total throughput is also significantly improved. The key idea is how to design the data structure here. So how we maintain an efficient prefix tree here. I think we did like several optimizations here. The first thing is previously we have to run tokenization here, but now we remove the tokenization overhead. We just do it at the character level. And also previously we don't have the eviction. I think now we also have a robust eviction policy, so it won't run out of memory. Yeah, I think that's pretty much it. So you are welcome to try. this is also, I think, the first open source well-maintained cache-aware router. If you have any, you have many workload with many shared prefix, you can try this.
Yeah, and we will add this a detailed document into our SGLang document about this router next week. And yeah. Okay, so maybe we can move to the fourth part, the speculative decoding.
Yeah, speculative decoding. We are trying to review and merge this PR. So basically, Ego, that's also a very nice and solid contribution. So basically, to support speculative decoding, we have to. So Ego. So basically, our plan is to support two kinds of speculative decoding. One is the Ego 2. I think it's one of the most advanced and fastest speculative decoding algorithm. And another one is the most simple but effective algorithm, which is n-gram prompt lookup. And to support them, we will probably on the core schedule level, it should be simple. We'll add a new forward batch mode, which is the target verify. So previously we have prefill batch, decode batch, and now we'll have a verified batch. After we add the verified batch, then we can support a lot of other algorithms. So this is one primitive we want. And then for all the Ego related stuff, we will put it under this folder. We will have a Ego worker. So it will handle all the Ego specific logic. And according to this contributor, they can get 2x speed up on small batch size and 1.x speed up on batch size like 16. So I think it's pretty good. And this is a very high priority, and we hope to merge this in 1 or 2 weeks.
Okay. Will we have this on our new release, or we won't for this to release our new release?
I think this is probably won't be in 4.4. This will be later.
Okay, cool. Are there any more questions regarding this part?
Yeah, I have just general question like, do we have the planning on date for the release time? We can know ahead of time. So
Okay, so this one, I guess, we'll put it out next Monday or Tuesday. I think everything is ready. We just need to bump the version number.
you mean router one?
Yeah.
Like everything here, like zero overhead batch scheduler, cache overloaded balancer, faster structure output. These are the major features for our 0.4 release.
Monday, Tuesday. Okay, cool.
Yeah.
Okay, so the final part is regarding a discussion session. We can sorry, I gotta open the document again. Yeah, last meeting we've basically discussed about our plans for SGLang in the nearest days, like before next year and in the first quarter of next year. The most important, there are several things really important. First thing is the multi-layer cache, or hierarchy cache, and the second is PD disaggregation, and also I don't know what's the CacheBlend, right? Yeah, and I think the multi-layer cache is the first priority in that.
Yeah, so the multi-layer cache, we also have a working progress. We also have a working progress branch. it's this branch. If you are interested, you can try that. I'll send it to the chat.
Okay. And also, yeah, and also for the PD disaggregation, we originally planned to do this in the first quarter of next year, but recently we see that Mooncake they are released their code version, and we have more members join our team to build this up. So so we will definitely have it move quicker. Yeah, and today I have another part to share about the code walkthrough. It's actually a lot of company wants to use SGLang for their second-hand development. So we are planning to make a document on the code walkthrough describing which part of the codes are doing whatever thing. And we now plan to do this for just one document and no more than 200 lines and just one figure. So I'm wondering about do any of you guys have opinions on what's a good code walkthrough and the developer? Say you want to add new codes, but there could give you a quick hands up. So are there any suggestions for this? Indeed, we do not see. I don't actually see a good example of code walkthrough, but I think that's an important thing for open source contributors. Yeah. Okay. But anyway, we have a channel on our Slack, and we will schedule the meeting early next week to discuss this feature. That's maybe not a feature, just a document. If you feel interested in this, and also if you're interested in the detailed codes of SGLang, maybe you can join our Slack and discuss that. And hope to see you in that channel. You can just direct message me on Slack, right? Cool. So yeah, and additionally, we have planned it to fully support OpenRLHF. I don't know if any of you guys are familiar with that framework. I can basically scrap it. OpenRLHF is a widely used RLHF engine in the academia, since in academia there's no that much GPU resources. So possibly we only have one cluster with eight A100. How can you train a 70 billion model using RLHF? Yeah, and that's what they are trying to solve. Currently, OpenRLHF are using VLAM, and they have a wrapper of VLAM to update parameter and initialize process group. But we officially support that to API in our frame in SGLang. And also next week we will definitely merge SGLang into OpenRLHF. I mean, give them a switch code give them a switch code, and they can directly use SGLang from OpenRLHF in OpenRLHF. And if any of you guys have interest in this part, you can direct me. And that's also on my yeah. So that's another to do on my list, right?
Okay, I'm new here, and recently I'm using VLM in the Monte Carlo tree search process to generate reasoning steps. And is there any timeline for immigrate SGLang to replace VLM here? So is there any repository I can refer to for guidance? And what's the yeah, that's my question.
Okay. Thanks. So you are using VLAM to do tree search, right?
Yes.
Okay, cool. I think that VLAM right now also has their prefix caching support, but maybe we are the first one to propose that. You can check our original paper on SGLang, and you can see in our paper we have a picture describing we implement SGLang basically for the tree search. So we have front-end language, somehow like the folk, yeah, like forking and stepping back on a tree. And I think that's pretty easy for you to do. So, and also you can directly check our documents. There's one called the front end. Yeah. Sorry.
Maybe I can answer that as well. So we have documentation here. A lot of API are pretty easy to use. You probably even don't need to go to the front end. So you can use either OpenAI APIs or the offline engine API. And then I think that's all you need. You can yeah, I don't think we need to go to the front end. Yeah, so that's my point. We can just use the OpenAI API or the offline engine API, and then the like all the optimization, like KV cache optimization for tree search will be turned on automatically. So you can just run the benchmark, and I think you'll get like higher throughput with SGLang.
Okay. Okay. I've run through the reasoning process using VLM, and I will try to use SGLang, and I will update the result later. Thank you.
Okay, so I guess think you are using some models like Llama, right? Or Coin?
It's actually AlphaMath. It's a 7 billion model, and it's point it is used in the inference time computing. I mean,
Okay.
Monte Carlo tree search.
Yeah. So I think SGLang is just optimized for all these use cases. So you can just use the OpenAI API or the offline engine API, and then you will, I think maybe you will just notice the system will just run faster. If it didn't run faster, yeah, you can post some questions on our Slack or GitHub. We'll take a look.
Okay, got it.
Okay, yeah, thanks for the question. Hey, Xinyu, you are here. I think you definitely have some question to discuss today, right? You told me before.
That's actually comes from me, I think.
Okay.
Actually, I'm using PRM like MSSheffer to get the logics, to get the reward of each steps. And since it looks like the online engine doesn't support MSSheffer right now as a reward model, so I use it as a text generation model to try to get the logics. So my question is how to get the logics using SGLang, like since if I just run the engine, it just gives me the output without the logics.
Okay, so yeah, you can use it's better to use the native API. I also give you a link here. So you can, here is all of our sampling parameters. You can set return log probe as true, and then it will return log probe.
Okay, thank you. I'll try that.
But I think maybe it's better to add to support that model as a reward model, so we can use like the proper API for that. It won't be very hard. Just a few lines of change in that model file. Maybe Chen-Yang, you can follow up with that.
You mean PRM, right?
Yeah.
I've described this with my friend. They are in the meeting right now, and I think it's also on my list to do. Perhaps just after supporting OpenRLHF, and I think OpenRLHF do really have interest in PRM also. Yeah.
Okay.
Yeah, we can discuss it offline later. Yeah.
Okay. Thank you.
Yeah. Also you can join our Slack, and we will have a channel for supporting this. Yeah, we do. Yeah, we do really want to support generalized reward model. I mean, someone told us before, say you have any kinds of causal language model, and after pre-filling, you can either go to embedding or go to decoding or into rewarding. So someone suggests us we can after the pre-filling we can just simply add a new MLP layer, and we fine-tuning the MLP layer for several times and directly using that MLP layer's projection as the reward of that causal language model. So that's also we want to support recently. It's on my list. Yeah, and someone even suggests us maybe you can do something like the rewards ensembling. Say you have one causal language model, and after pre-filling you get one logis. Then you go to several MLP. I mean, I do not mean several layers of MLP. I mean several MLP, and each is one layer, and you get several rewards, and you can somehow re-ensemble these rewards together and to get the final fine-grained rewards. And there are papers supporting this new usage of rewards, and we also want to try out this idea if that's workable. Yeah. So maybe we can go offline and we can discuss this. Yeah.
Okay, that's a good idea. Okay, thank you.
Okay, yeah. So what we have for today? Hey Demi, do you know what's the CacheBlend on the timeline? I don't understand what's that.
Okay, ignore that for now.
Oh, okay. So, yeah, maybe, yeah, we have a quick meeting today. But anyway, we plan to release our next version recently. So, yeah, would we specifically do that?
Monte Carlo tree search.
Oh, hello. Are there any question?
Question.
Oh, okay. Hey, hello.
Hi, I actually have a question. So when you're like trying to sample multi times for decoding, like is it better to set the n the like the when you're sampling, is it better to set the sampling parameter of the n to like some larger number of samples, or like copy the prefix for multiple times? Like
I think it's
also
bad.
I'm not quite sure about like how the prefix like cache, the prefix caching works. Like I feel like if I enable the prefix caching like manually, or I do not enable it, the efficiency does not have a significant change, something like that.
So you just run a default server, and I think you can use the n argument to sample multiple sequences, and you can monitor the cache hit rate. It should be like much higher if you sample multiple times, and then you can kind of verify that. And what did you see? Like,
so the other option is copy the prefix for multiple times. Like,
yeah, you can also copy the prefix for multiple times. I think that should also work.
I think empirically, they like copy the prefix for multiple times works faster. I'm not quite sure. Like, yeah.
Okay, so you find copying the prefix multiple times runs faster.
I'm using the offline version.
Okay.
Not the yeah.
I see. And you send a big batch together.
Yes. Right? Like I batch everything together.
Okay. Yeah. So yeah, that I think what you observed is correct, because when you use the offline engine and together with that n sample, there is some like minor implementation detail that makes them didn't work well together. I guess yeah, you can just copy the prefix. That's probably faster.
Okay, I see. Thank you.
But if you use an online server and you send many requests, like you use multiple Python threads to send many requests together, in that case, probably setting n will be faster. But I think yeah, there are some subtle details on how we handle the n.
Okay.
Okay. Yeah. Okay. Good question. Will we ever release our next version in the next week or some specific
Yeah,
date?
next week.
Okay, cool. Yeah, so are there any more questions? Yeah, if not, yeah, then thanks for joining today and happy Thanksgiving. Yeah.
Okay. Yeah. Thank you, everyone.
Yeah.
Bye.
And we will share all the slides and documents online and hope to see you guys in our Slack channel. Yeah. Bye.
Bye.